and inside the pipe you will have some orifice to have for the air can cooling the battery inside here. You see the outlet is the air will go out here and go in here, the orifice. This is some results. So you see, actually CFD help us a lot to design first, and then we can check even the diameter of the orifice, and then have the very correct result. The third type is reverse airflow. In the field of battery, you can arrange for the inlet and outlet. So in the past, we always use one way, it means that in and out. But now we think that, for example, one in and two out. But with the arrangement like this, so it will help or not. And we don't need really make experiment. We just use CFD, and this is some result from this order. So you can see that for the classical type, the temperature maximum is very high, but with the reverse flow, you will have a lower maximum, and the distribution is better. With the liquid cooled PTMS, actually nowadays many manufacturers confirm that actually airflow is not good as the liquid cooled PTMS. So they have many types of liquid cooled PTMS: direct contact with fluid, indirect contact with fluid, and we will focus on the cold plate. Let I explain a little bit about cold plate. Okay. The cold plate, this means that if you have the batteries and you will have to use a plate with many channels, and to input the cold liquid to transfer the heat for the battery. And in the cold plate technology, you will have the parallel channel and serpentine design. For the parallel channel, you will have many channels arranged in parallel on the cold plate, and then perform your heat transfer. With clearly that with simulation, you can do anything you want, because from 2 channels, 3 channels, 4 channels, and also you can assume that the flow direction, for example, the same flow direction, the reverse flow direction, etc. And this is some result I take from the paper, and this is temperature distributions. And with the serpentine design, this is very new techniques, because instead of use many parallel channel, they will use a channel with many shape. For example, the U shape like this. And you see, you just use simulation, very simple to have the full result. And we have a pre-design to know which one is better. Besides that, you can also use CFD for the process of the optimization. For example, in this paper, they have the shape of the channel like this, and then they have some dimension. They say which one is best for which one is the best. For example, the width of each dimension, so they can optimize that, and then use CFD to prove the ideas. So the Ansys is also result from Ansys Fluent, and from all the results you can see that CFD supports a lot in this field, and we also have some conclusion that liquid cooled PTMS is better than air cooled PTMS. And in the future, maybe they will develop PCM, and PCM also we will use the CFD to support for that development. That is all. Thank Thank you for your attention.
Okay, thank you, Dr. Kwan.
I start.
Yeah, please stop sharing. And Papa, can you kindly share? Let's have a voice test. Can you talk right now? Hello, Papa. Um. Okay, I think he may still have the voice issue. So now I'd like to invite Anas from Cyber Systems Malaysia to give a presentation about the Ansys MBU solutions for structural performance of automobile. Okay, so Anas, can you kindly share your screen?
Right.
I can hear you well, and then okay, now I can see your screen now.
Okay. Right.
Okay. Yeah.
Okay, Mary, you can go.
Okay, and Anas is the Ansys CFD and Mechanical Application Engineer in Cyber Systems Malaysia. And in the presentation, he's going to talk about the body, chassis, drivetrain, and even battery case about anything about the structural aspect. Okay, so now, Anas, you can move forward and uh, make the presentation. Thanks.
Okay. Thank you very much, Mary. Appreciate that. Okay, hi there. My name is Anas. I'm from Cybernet Systems Malaysia, and I'm currently based in Kuala Lumpur. So my presentation today is going to be about the structural performance of automobile. So when we talk about the automobile development, in terms of product or design, structural performance is one of the important aspects that need to be focused on. So today, let's go through how we can take advantage of computer simulation in the design and also development of an automobile. Okay, so first, a little bit of introduction about automotive industry and also structural simulation. Then we will go through how structural simulation can be used in the automotive development. Okay, so the automotive industry has been one of the strongest and also most well-developed industry compared to the others. Over time, as the growth of an automobile ownership increase, requirement for an automobile to be more safe, more economical, or even more affordable are also increasing. So in the automotive industry, actually structural simulation has been widely used in the design and also the analysis of the automotive parts. It is because structural simulation actually provide a very strong support for the design and analysis for components, automotive components such as the suspension systems or the chassis or the wheels and also other kind of automobile parts. So why do we need to do structural simulation? So structural simulation actually helps engineers to understand the structural performance of their design. So that includes something like the stress strain of the design, which subsequently allow us to evaluate the safety factor of the design. And also include the deformation of the design, the vibration response, the overall design weight, and so on. So a few examples of the analysis that are most commonly done include the composite analysis or thermal analysis, impact analysis, optimization, so on and so forth. So there are many kind of analysis that falls under the structural simulation. So ultimately, with the structural simulation, you can reduce the cost and also time of your product development without having the need to build a large number of physical prototypes. So instead of build physical prototypes, what you can do instead is that you can simulate everything in the computer first, and then later on, you can decide which design is the best, and then you can proceed with building the physical prototypes. Plus, with the ever-increasing requirement for a safer and also more economical automotive products, structural simulation actually can also help in meeting this kind of requirement as well. So the adoption of structural simulation in automobile development can be seen in several parts and also components of a vehicle. So here are some of the automotive parts that can adopt structural simulation into its development. So we are talking about components such as the chassis and also the body of an automobile, where we would like to analyze something like the structural integrity or the safety performance of the chassis. And then we have the drivetrain, which include parts such as the drive shafts or differential or maybe transmission, where the dynamics and also durability of the parts is crucial. Then we have the wheels, where we may want to further optimize the design in terms of the material use and also maybe the shape of the wheels. Next, we have the suspension, where we would like to analyze something like the kinematics and also compliance of the suspension, or maybe you would like to know the structural durability of the suspension components and so on. Then the automotive interior as well can actually take advantage of structural simulation, where we can evaluate something like the maybe optimized shape or structural integrity of the components, the interior components of the vehicle. So when we talk about the chassis or body of an automobile or vehicle, most common challenge would probably be the overall structural performance of the components. So something like the fatigue life of the chassis, or maybe the torsional stiffness of the chassis, or whether or not the chassis meet the crash standards rating and so on. So those are some of the challenges that engineers may face. So Ansys have multiple solutions for this kind of problem. So we can use Ansys Mechanical, for example, to do static structural analysis, where we can evaluate the stresses or the deformation of the chassis. We can also do fatigue analysis to evaluate the life of the parts and also determine how long before it fails. And then for crash analysis, Ansys has the Ansys LS-DYNA, which allows for the explicit dynamic analysis. So the user can basically set up the crash test environment inside the Ansys LS-DYNA view. So these are just some of the analysis example that you can do with the structural simulation. So one of the example here is the life prediction of the welded joint. So if you are if the means of connection you are using is a weld, then you can definitely evaluate the life of the weld joint and also include the material properties such as SN curve in your analysis to evaluate such kind of phenomenon. And then another example here is the SAG evaluation of a car door, where you would like to evaluate the deformation of the components due to gravity or maybe other kind of loading as well. And then you can also determine the chassis strength when subjected to an impact loading. So something like a roof crush analysis. So drivetrains are another parts or components that can definitely take advantage of structural simulation. So some challenges that designers or engineers might face when designing the drivetrains components include something like the kinematic behavior of a drive shaft, or the durability of a transmission component, or maybe something like the dynamic behavior of the differential and so on. So for dynamics problem, Ansys has the multi-body dynamics analysis capabilities, which can help to address these challenges by providing the insight on the interaction between parts and such as gears or shafts or joints and so on. So we can evaluate something like the stresses being developed on each of these components as well during the dynamic operation of the components, or even predict any sort of misalignment on the joints or the connections between the components. So one example that I have here is the multi-body dynamic analysis of a transmission assembly. So this analysis was done to evaluate the synchronization characteristic, when DCT gearbox is in shifting, when you try to shift gears. So the simulation was done using one of the Ansys product called Ansys Motion, which is a specialized tool for multi-body dynamic simulation. As for the simulation model, all bodies here are connected to one another using appropriate constraint, context definition, and also joints. Then as for the input, the sleeve actually initially rotating at 694 RPM. And then as the result, during the meshing process, we can determine that the gear meshing process took about 0.683 seconds for the meshing process to take time. And also based on this graph here, we can determine that the gear is synchronized well. Next here we have wheels. So wheels are another part of an automobile that many people might be interested in because wheels actually contribute to the unsprung weight of a vehicle, of a certain vehicle. So the goal is actually to always reduce the weight of the wheel as much as possible. So therefore, some of the challenges when developing a wheel revolves around optimizing the design shapes of the wheel and also the material used to build the wheel in the first place. So, you know, when we talk about wheels, some of the common material that's been used to make a wheel something like a steel or aluminum alloy, while carbon fiber as well may also be seen in some of the more high performance vehicle. In this case, Ansys have a solutions called Ansys Composite Purpose, which allow us to design the composites layout definitions and also evaluate the carbon wheels structural performance and also its composite failures. So here an example of composite wheel design and also composite wheel structural analysis. Basically, this analysis was done using Ansys Composite Purpose or SCP for short. In this case, we created the fabric, the composite fabric using the epoxy carbon woven prepreg with a thickness of 0.4 millimeter. Then the fabric is being used to define the stack up properties, which then allow us to configure the layout sequence and also fabric orientation. In this case, with the orientation of 0 and 45 degrees.
Something drastically wrong, man. I changed the laptop, even that laptop is also not working.
I'm sorry? Okay, so in this case... What does
she say? She has to cover your topic or it's dropped now?
I don't know, like I tried second time.
Papa, I can hear you now.
Is working, but this one, like when I enter in actual this one, I cannot.
Okay, Anas, please go ahead.
Yeah. Okay, let me continue. Sorry about that. So yeah, in this case, I specify the fiber orientation of 0 and 45 degrees. And then firstly, we can evaluate the strength of the composite layout by analyzing these polar properties of the composites. And then afterwards, we can, evaluate something as we can observe the layered composite thickness and also the orientation across the all surfaces. And then after we finish designing our composites wheels, we can transfer it to the static structural analysis, where then we can evaluate the structural performance of the composite failure. So we can observe something like the region of high stresses, which in this case were found at the hub region and also the leading edge of the spokes region. Okay, so next we move to the suspension. So when it comes to suspension design, aspects such as the kinematics and compliances of the suspension system need to be taken into consideration. So, and then apart from the dynamics of the suspension, the structural performance and also durability of the suspension component, such as the arms and also the knuckles, also need to be evaluated as well. So again, with the multi-body dynamic analysis, we can predict the kinematic behavior of, and also the, kinematic behavior and also the compliances of the suspension systems, like springs, under any types of loading conditions. And then, of course, you can also perform a structural analysis, so to evaluate the stress being developed on each of your components of your suspension. So here we have an example of a multi-body dynamic analysis of a suspension system. So in this case, actually the ground is subjected to a vertical motion, and then the sway bar is also being subjected to the horizontal motion. And then all of these components of this suspension assembly has been constrained using appropriate contact and also joints. And then as for the results, we can evaluate something like the forces of each of the springs throughout the duration of this simulation, which in this case is 1 second. We can also evaluate something like the gap and also the duration of which the tire is not in contact with the ground. And then of course, we can also evaluate something like the stresses being imposed onto one of our parts, which in this case is the knuckle part of the assembly, which in this case have the maximum equivalent stress of 103 megapascal, around 103 megapascal. Right, so lastly is the interior components of an automobile. So interior parts actually may be subjected to a certain types of loadings, and also require some sort of clever design to maximize the structural performance, and also helps in making material selection process and also subsequently reducing the overall cost of the design. So some challenges may arise when it comes to the interior parts of a vehicle, including something like the thermal expansion of a dashboard, for example, under constant heat. Or maybe some people might be interested in finding a way to optimize the shape of some of the interior components. So ultimately, this kind of problem can be solved with the help of structural simulation. So with Ansys Mechanical, for example, you can evaluate the temperature distribution across the entire components of interest. And also you can evaluate the subsequent stresses and also deformation of the components due to the thermal expansion. Okay, so here is an example of topology optimization, which in this case is for the pedal design. So actually we started off with a original design, which is weighing at about 240 grams. And then afterwards, we can do structural analysis to evaluate the original stiffness or deformation of our design. Then afterwards, we can specify our design objective, which is in this case, we would like to maximize the stiffness. And also we can also add some kind of a manufacturing constraint as a boundary condition as well, which essentially allow us to create a more feasible optimized shape. Then after the optimization process was done, the new optimized shapes design can be verified using the same boundary conditions and also loading like the original design. So as for the results, the maximum deformation of the new design is about 0.7 millimeter compared to the original 0.616 millimeter. So although there is a small increase in the max deformation, actually the final mass of the optimized design is 143 grams, which is about 40% less than the original design. Okay, so next I would like to talk about perhaps one of the perhaps the most important component of any when we talk about structural simulation, which is the material data. So the next part is going to be a little overview of the Ansys runtime material data for simulation, or Ansys runtime MDS for short, which is essentially a detailed and also comprehensive material data library for simulation. So generally, most of the, any vehicle, automobile is made of the metals, plastic, rubbers, and others, something like composites, for example. So according to statistics over time, non-metal material classes have gained more and more popularity in the automotive industry. So this is mainly due to the, ever-developing material science, also material technology. Many materials such as polymers and also composite have been, stronger, lighter, and more durable than metal in some cases. So therefore, nowadays, as an automotive development, when we talk about automotive development, the options of material that engineers can choose from becomes wider and also much more diverse nowadays. So more materials included in the design and also development of a product means that when it comes to simulation, more material data is required. So Ansys Granta was developed to actually help users of Ansys to maximize their use of this kind of use of their simulation tools. So we found simulation engineers were faced with three challenges when it comes to material data. So the first one here is time searching, assigning, and also formatting material data into simulation. And then the next one is the different material name used, when it comes to departments within the same company. And then the third one here is simply the inaccurate material data, which can subsequently resulting in the poor simulation accuracy. So basically, all of these will lead to a more, repetitive simulation workflow, a poorer quality simulations, and also overall lower the engineering productivity. So essentially, the benefits of Ansys Granta can be broken into three. So you have the accessibility of the Granta MDS, which is basically embedded in any of the Ansys simulation tools. So you can find it inside the Ansys structures or Ansys electronics or even Ansys fluids. So it means that engineers have access to the right material in a few clicks. And then secondly here, the material data available in the in the Granta library are actually already in the simulation ready format. Therefore, engineers can save time from having to search and check for material data from a variety of sources, and then subsequently slowing down the simulation processes. And then finally, actually, is the trusted data. So MDS leverages the Ansys Granta's market-leading materials to bring a trusted data set of over 2,600 materials with a 20 plus material properties. So yeah, with 750 plus material classes and growing, MDS actually offers a broad coverage of material classes. So that include material classes such as metals or plastics or ceramics or woods or composite glasses, foams, so on and so forth. So there are many material classes being included and also many kind of material properties also made available inside this kind of library. Okay, to summarize everything that I've just presented just now. So basically, the structural simulation has been widely used in mechanical design of automotive parts. It is simply because with structural simulation, we can actually reduce the cost and also time, time of the product development by essentially eliminating the needs to build a very large number of physical prototypes. And also as seen from some of the example, Ansys actually provide a very comprehensive structural simulation capabilities for design and analysis of automotive products, automotive components such as the suspension, chassis, wheels, and so on. And then finally, we can understand that an access to a comprehensive material data library, which in this case come in the way of Ansys Granta MDS, can actually boost the productivity of simulation engineers. So that's all from me. Thank you very much.
Okay, thank you, Anas.
Yep.
Okay. So next, I'd like to welcome Dr. Nicholas from Cybernetics Systems Taiwan. And then Nicholas is going to talk about Ansys HFSS and then EMA 3D co-simulation of vehicle circuits and cables in electromagnetic field for automotive electronic application. Okay, Nicholas, can you kindly share your screen?
Okay, can you hear me?
Yes, I can hear you well. Okay. So
Okay,
Nicholas,
my screen.
yeah. Yes, okay. So Nicholas is the Ansys HFSS application engineer in Cybernetics Systems Taiwan. And then this talk will focus on the simulation cases and solution of Ansys HFSS, Ansys SI Wave, and Ansys EMA 3D co-simulation of vehicle circuits and cables in electromagnetic field. Okay. So Nicholas, you can now go ahead for your
Yes,
presentation.
thank you, Mary. And hello, everyone. My name is Nicholas, and I'm from the Cybernet. Today, I will introduce, as far as you know, the Ansys HFS and EMS3D code simulation of vehicle circuit and cables in electromagnetic field for the automotive electronic applications. And talking about automotive electronics, we all know the 5G communication is developing very soon. So there are many device will becoming a new requirement for the automotive electronics. And we will considering the design way to reduce our cost over time. Maybe we should put in our product in the market very soon. So we need to do some simulation for our automotive electronics designs. So let's go to my slide, and I will show some solution and maybe the platform of tool to introducing to you how about the Ansys to design this circuit and the cables in electronic magnetic simulations and to automotive applications. So let's go to automotive system design challenges. And the first is the mobile revolution continues. So we will considering our device is very small and integrations. So we need to using the many way to measurement and testing our device. But you need to more faster and low power device. You should considering more design. Maybe we should need more idea to reduce our size, and the cost will be a key in this design decisions because there are many kind of device they will put in the different way, and then there are many sensor in the car. So if the cost will be hidden in our products, there will be customers will ask us to reduce our cost. So and the the other way we will talking about the motor design. The motor design considering the more efficiency and the performance for the EV cars. So in due to the 5G and EV car development, the motor design will be a key to these industries. And the next is a new requirement, and the new requirement will be maybe some power efficiencies and wireless and ADAS systems. The ADAS systems will be a self-driving key rule of the all systems. And if you want to build a level 2, even a level 3, you should put in many sensor in a car. So we were considering the ADAS system design will be not follow the method of the try and error, because there will be old method, and there will be that your design time, it will be long time to design your products. So we will considering about the simulation to do the ADAS systems, and the analysis of the antenna performance into the radar is the basically way to the ADAS. And the advantage of the systems designs is the old systems considering, and maybe you will put in the ADAS and radar in the environment to measurement, and maybe the simulation will doing this thing in at the same time. They will reduce your testing time. And the next is the EMI and RFI effect. And talking about the new challenge of the automotive, the EMI will be certifications in the our products. So we will considering the reliability, maybe some systems, but not the most important thing is the EMI, because the certification is plain layer. So you should doing the certification, there will be your product to the market. So we were considering about the simulation is very important thing in the automotive system designs. So let's go to why we need to electronic simulations. The electronic simulations will be advantages of simulation to do the help you to do the testing and the measurement. They are very reduce your cost because of the simulation will not replace the measurement. They will be help your measurement is more efficiency. So thinking about the simulations, we will put in the same environment with the measurement and reduce the testing time, and you will be very efficiency to do the your product designs. Now, we need to introducing some simulation platform to you, and there will be a EBU tool, electronics tool to you, and the Ansys will providing many well platform that is called the Ansys Electronics Desktop. The electronic desktop is the electronics magnetic studio, and the single unified desktop for the electronics tools. They will combine the HFS and Q3D, even the circuit together, and I speak they will set in the same interface, even the Maxwell's. So if their interface is similarly, you were learning those two are very fast, and the design will be in the same platform, so you can doing multi-physics simulation for your products, and this is a powerful platform to you, and you were using those tools to do the design from the antenna, for the motor, and for the cooling, and for the some sensor of the systems. Even the system level simulations, you will be using the simpler and to do some simulation, like and they are called the team builders now, and those kind of simulation will help you and to do the system level simulations. Let's look at simple example for the electromagnetic analysis. We're using the motor case to do some some simulation for you. First, you will follow the motor case and to explore the motor model in 2D, and you were using Maxwell to simulation the 3D and magnetic FEA analysis. And if you finish that, we will put in the Ansys simpler or twin builder to do the power electronic circuit system simulations, and there will be a system level simulation in this platform. And if we want to also get the thermal analysis, we were using the ice bake. Those kind of tool were in the same platform they call ADTs. And if you need to RCG, extract the RCG, we were using the Q3D, and you will extract the parameters, and we were using the SI wave and HFSS. Those kind of simulation, we will be in the same platform they call ADTs. But sometimes we need we will make some structural problem. They were using the mechanicals, and something we're using the CFD. So we have the Ansys workbench, and there are good connection for the Ansys structures and Ansys CFDs. So a motor design flow will be created by by those tools. We may design our motor in this platform, and we will get the many results and many physical issues, and they will be reduce our design time, and they will help you go to market very soon. So you can start with the design analysis and dynamic response and the radiations and sound analysis. There will be a simply way to do the MVH variations. So we will, if there is more motor problem or issues, you please feel free to contact with us. We will providing the very complete platform and solution to use. If we finish the motor problems, we will go through in the ADAS problems. The radar will be ADAS key point of the designs. First, you will using the different server in the radar systems, and the radar sensor design and analysis will be many one to consider in the designs, and the radon will be a key way to do the radars, because the radon will be a factor of the antenna performance. First, we will design our antenna and our array in the HFS. Second, we will put in the antenna to the radon. The radon will be analyzed by the HRS very soon, by very efficiencies. But now, if we finish this kind of antennas, we will be spend many time, and there were a high time cost of the simulations. There are many people ask us to reduce the simulation time, so we will help you to develop your HRS platform, and you using this kind of tool very well. We will introduce the HRS server and help you to fast your different way issues. Like the antenna, we will introduce the FEM servers, and antenna and radon, we will using the hybrid regions, and the antenna and the actual radon, we will introduce in the shooting function rate solution to use. There are different server will reduce the simulation times. But in the new version of HFS, the HFS will combine with the shooting function rate. The shooting function rate will simulation the dielectric material well, and in the old version, the shooting function rate just only can simulation the metal material. And now we will introduce the new shooting function rate simulations. First, we will compare these two results of the HFS and the shooting function rates. The HFS will simulation the radar very well, but you will be a high cost of the simulations you using the 32 core and the 300 more than 300 gigabytes RAM. And you will spend 4 hours to do the simulation. But in the same case, when using the shooting function rate, there will be joined to a GPU, and you just only 2 minutes, and you can get the same result of the same case. So the shooting function rate is more efficiency in the radon simulations. Now, there we are solved two issues of the electronics. There will be 3 points we will focus today. First is motor, and second is ADAS systems. Now, finally, we want to go to the EMC. The EMC issues will be halfway to simulations, because the test and measurement technique is very long time for the developments. So maybe we will using the simulation. Now, the there are some EMC tests and some chamber and will make it up in the this kind of simulations. And sorry, the most important thing is we will a new method to do the EMC simulations. That will be EMA 3D. The EMA 3D will be the you can work thinking like they will simulation the electrical electronics and they will modeling your cables, and we were thinking about the EMC problem will be the middle line. The cable is if the cable is straight, so we will be make up the EMC problems. But in the cable will be a middle lines. The different way to the cable will be some radiations in the corners. So we will considering about the cable radiations in the old systems. But in the cable modeling of the HFS, there will be some big cost of a simulation because you need more measures and more simulation time to do modeling your cable. So we were introducing the new tool of the Ansys is the Ansys EMS 3D cables. The EMS 3D cable will be totally a cable tool for the Ansys, and there will be just put in the KPL file for the EMS 3D. They will building the old cable in the interface, and you will simulation those cable in these tools. So now we will using the cable simulations and the total car models, and you will simulation some cable problem in your device. Now we will put in the cable and simulation the EMC problem. Even the EMI level of the antennas we can use in EMA 3D to simulation very well. You can get many result like the antenna in the low frequency efficient the interference. So we will doing this kind of antenna to put in the EMS 3D to do some simulations, but you will interested in the what is the difference in the HFS and the EMS 3D cables. This those two will be a full wave simulation for the electromagnetic fields. So first is the HFS model in the left hand side, in the right hand side, and the EMA 3D model in the left hand side. They are same way to do some magnetic lossy materials in the models, and there will be a lump pole sitting in the HFS and the same pole sitting in the EMA 3Ds. Now we're looking at the EMS 3D cable performance and the HOS. There are good agreement of each others, and there will be no nothing to carry about the EMS 3D. There are great accuracy and more efficiencies to do the same simulation with the HFSS, because the model of the cable will be complex, and there are some isolations, and something will be hard way to do some modeling in the HFS. So we were using the EMS3D to do the cable simulations, and you can put in the EMS3D simulation result with HFS integrations, because the EMS3D will explore all cable simulations and characteristic to the HFS. HFS will follow this cable characteristic to do the simulation in the PCB. Like the IBIS model will bring together, so you will get the accuracy model in this kind of simulations. And even you can put in the HOS near field result to the EMS3D. The EMS3D will analyze the electromagnetic field in the same environment by the HOS near field results. So there will be a co-simulation between the EMS3D and HFS. So there will be simulation results, and the EMS3D output the cable characteristic and the cable performance will interface of the interference of the our package and our IC. So in the TVS diode will be put in this PCB, and this kind of simulation will be help us to do some PCB simulations more and more efficiency, and will combine with the cable interference. So I think I finished my presentation. Thank you, everyone.
Thank you, Nicholas. And now, although we are a little bit delayed, we still have 5 minutes of break, and we'll come back after 5 minutes. Thank you. Hello, Papa, can you hear us? Hello, Papa?
Can you hear me?
Yes.
Okay, so lately I realized something, and you will be amazed that this is just because of our the system has blocked the WebEx audio.
Okay. It's okay.
So that's the reason I was struggling in the. I came to office just to make sure that I don't have a network problem, but it happens opposite. But anyway,
It's
do
good
you
to
see
hear
my?
you, Papa.
So,
Do you see my?
yeah.
Do you see my desktop?
Yes. So we can
And
hear
it is
very
changing?
well. Yes, no problem.
Okay, sounds good.
I
Okay,
just want
I'm
to
using
also
a.
confirm. Yeah. I'm sorry. I also want to confirm if
Yeah, I'm
Evan
using a mobile
finished.
network. Sorry, go ahead.
Okay. I just want to confirm Avanish and then Bat audio.
Yeah,
Because,
no, they are
Bat
not
is
in
on.
office, luckily. So I spoke with Raghavendra, so he
Yeah,
is able to speak properly.
Yeah, but here, can you hear me?
Yes,
Yes.
Bat, yes.
Yeah, I can hear.
Okay, let me just quickly start my video as well as share the content. So if you are able to see this.
Okay, no problem. We're now in practice session, so
Okay, okay.
no problem.
So I'll stop sharing. You can
Yeah.
share.
Yeah. Okay, so do you see my screen?
Not yet.
See it here?
Try again.
No?
I just make you a presenter.
Okay, I shared it. Is it okay now?
Now I still cannot see your screen. Could you find the share button? Okay, now it's It's okay now.
Yeah,
Okay,
now
you
it is
see full
visible,
screen, right?
Yep.
Okay, okay. Slide is moving and okay. So looks good.
Yeah, looks good. Thanks.
So let Avinash also try once.
I'm Marie, is my voice clear?
Yes.
Can you hear me loud and clear?
I can hear you well.
Yes, Avinash.
Okay, thank you. Let me bring my screen.
Yeah.
Okay, no problem.
I have a few videos. Maybe I'll just quickly try if those videos are fine. Yeah. You're
Is your video with sound?
Is it okay?
Yep.
你有听到他的影片吗？
Is there sound in your video, or it's muted?
Your videos are having sounds also, Avinash? Avinash? Hello?
Hello?
Not sure. Maddie, you can hear me?
Avinash, we don't hear you.
You can't hear me?
Yes.
I can hear you.
Yes, we can.
Okay.
But
No, maybe then Avinash got lost actually. Oh my God, it's a problem. Yeah, I think we can restart now probably.
Start now for the
Yeah.
next half. Okay?
Should I share my desktop?
Yes, please. And I will introduce you again.
Yep.
Okay. Hello everyone, welcome back. So in the next half sessions, the first would like to invite Dr. Kumar Salui from Ansys Inc. to talk about the Ansys overview for automotive solutions. And this overview presentation talks about how Ansys solutions can help to innovate in automotive designs. Okay, so Babha, now you can go ahead. Thank you.
Thanks, Mary. I hope you can hear me now.
yes, we can hear
No
you.
problem.
Perfect. Okay. Hi, good afternoon all, and apologize for the slight mess up that just because of the network that happens this morning. And I'll be talking about the Ansys overview of the automotive. I was just thinking that while I was trying to connect, and I saw there are a lot of issues on the network and all. And at that same point of time, we, like in regular day in, day out, we see a lot of challenges in our life. And so as in the same way the industry also works, like industry also faces a lot of challenges. Okay, and here we are to address some of those challenges, may not be all, but some of those challenges pretty easily. So, but before we are getting into that part, let's talk about, just Ansys. This is introductions to the company. So we are a global simulation leader, a simulation provider, and we have 5,000 plus employees globally, and having offices in 75 offices in 40 countries. And we are all focused into the simulations only. And we are a proven technology, and out of 100 Fortune 500 companies, the top 100 Fortune 500 companies, 97 are using our solutions. And over the years, we have many strategic acquisition, and we have also many technology partners. And we do continuously invest on research and development. And if you're looking at talking about the challenges, we are moving very fast. The technology is changing almost every day, and we are moving very fast towards the electrifications of the automotive industry. And also, not only that, with the 5G in place, till 2025, you will be seeing a lot of disruptions in this industry for the 5G intelligent connectivity, and also usage of 5G for artificial intelligence and Internet on Things. So there are a lot of investment in the 5G connectivity on research and development. Not only that, a big part of investment that comes into the simulations also. And so as we are moving towards the autonomous driving systems, and again, there are a lot of investment. So these driverless cars need to be tested, and it required a lot of testings for these cars to ensure the safety, and also the priorities are given to emergency vehicles, etc. So, but if we do not do, or if we do not use the simulations in this field, what would happen that it will take ages to come out with the autonomy. So all the industries are actually, trying to achieve these goals to come out with their driverless cars, and where simulation works quite heavily. So it requires a lot of simulation work to, to address a lot of different challenges, or these challenges are quite new. And these tools or these solutions helps them to reach at the market faster than it is expected. So Ansys simulation platform drivers against the business initiatives. It's a 33% decrease in the engineering change orders. So a lot of times we face issues due to, like the things are not working properly. And then it requires improvement every day. We are, because of, the market competitions, it requires the cheaper but safer and a better design. So it is 22% of year-on-year improvement in total cost per unit that's been seen when the industries are using Ansys simulation tools, and 21% of year-on-year increase in the operating margin also being observed by different companies. 34% greater raw material utilizations, and 11% decrease in the physical prototypes, and 14% decrease in length of development time. So, and this came out from the survey. It is not by us, by a third-party company. It's called Aberdeen Group, who did and showed that, these multiphysics simulations of Ansys, it helps in various way. And 71% of these customers are actually using best-in-class simulations, and all other people, about 37%, are using different other type of simulations. And also many of our customers, they're using a multiple physics, what we call as multiphysics solutions for the virtual prototyping of their designs. So what are the simulations what are the field that simulations can help in the automotive design? First of all, the exterior. When you talk about the movement of the car, it requires, we always try to reduce or minimize the resistance. We minimize the noise that is being generated from different parts, because for example, just a simple example, if you think of car is moving very fast, from your side mirror there could be a lot of opportunities of creating noises. So we would like to reduce that noise, or we would like to reduce the resistance. So that's exterior designs with the external aerodynamic simulations could help us to achieve those goals. Similar way, we can have interior designs. For example, like if you're sitting at different locations of the car, you should not, because of your AC is operating, you should not, like feel that one place is a little bit warmer than another place is colder. So which is not I mean, which is not, we don't want such kind of situations. So, and again, like we need to have stronger cars, which is higher reliability. For example, like chassis designs, so we can have the mechanical designs, and then we can have highly efficient internal combustion engine for our conventional cars, or for the electrified powertrain. We need to have another efficient system, and we should have a very nice cooling system to ensure that the engines are not hot enough, or there are connectivities required for electrical and electronic systems are there. The sensors are there inside it, so this should function properly. Full vehicle attributes simulations you can do. Also, as we mentioned, talked about like ADAS and autonomous driving, or manufacturing, and digital engineering. So all this field, Ansys simulations can help you to design, come out with a better design, or even if you have some kind of issues, it can help you to find out what could be the issue. So how it simulates the future mobility, or how it helps. It's basically has various ways. Again, like it can help, as we talked about, connectivity, the artificial intelligence building, the battery technology, or creating the stronger or reliable structures, or developing integrating sensors that could be that is used in the modern cars, or designing vehicles with low drag coefficients. So various ways it can help with the newer designs of the car. And as you have already heard, I mean, our colleagues will be talking more about these things. They have already spoken about the computational fluid dynamics and electronic solutions. And my other colleagues will be also talking after my speech. They'll be talking about the system and the system engineering part, as well as the lighting systems, etc. So we have various solutions which actually helps for comprehensive multi-physics simulations, and also helps the automations and optimization. So we have simulations on the what you can do. You can do like the design explorations, or you can solve for the structural issues or the fluids challenges, electromagnetic simulations, or even you can do the optical or semiconductor. This one. And we have various products which helps to for this type of simulations. We can have the additive designs products, or you can simulate for the structures. For example, like if your vehicle crash, what could happen? I can use our solutions for doing the crash analysis, or you can have like structural issues, reliability issues, or you can have fatigue issues, where you can use our structural products, or maybe like you can have the internal combustion engine, or external aerodynamics kind of issues. Those can be solved using the CFD solutions. Even our solutions can actually help you for doing the painting. For example, like various cars could have, cars could have even challenges for doing the paintings. For example, like, like if the air bubble forms inside the cars, it could be like that part could be wasted completely, or they need to cut it and they need to test it out to see like what is going on. So even CFD can help you to predict the painting, and the painting works properly. Similarly, electromagnetic simulations, you have already heard about it, and my colleague will be talking about more on optics and photonics, and also we have solutions on the semiconductor sides. And my colleague will be also talking about some of the safety and also the software functions and the capabilities of Ansys. And also we have solutions about, like even if you have the car is moving, we can simulate the noise, etc., to find out how, how your comfortable car could be. And also we have hundreds of libraries to solve the automotive solutions. These libraries could help from interior till exterior chassis, power electronics, or even IC power trains, or vehicle systems attributes, and also various other things. So you can use these libraries once you have this access along with the software to solve various kind of problems very quickly. And these are certain things that we are working on the R&D sides that we would be, as we mentioned, that the technology is changing very fast, and 5G connectivity enable us, to build more artificial intelligence and also machine learning kind of challenges. So we are working on that. We are also working on developing the platform for multiphysics simulations, which is already there, but we are further developing for seamless simulations and visualization process, and also multidisciplinary optimizations. And we are using the cloud services and developing our solutions on the cloud to make it much more faster and easier for our users. Then we are also working on the hyperscale simulations and collaborations in the cloud. For example, like we are using the modern technologies like GPU, and also the existing technologies like SMP and MPI kind of to make it more efficient. And also predictive, and we are working on the predictive and robust designs, also working on digital and physical world, and the digital transformation computational methods on various new areas. And also we are working on machine learning based flow solvers, generative designs to make it more automated, and automated mixed mode, 0-dimensional to 4-dimensional, and MF and MS simulations. And finally, these are some of our renowned customers. This is just a very small list. The entire list could take itself the entire seminar time to describe all their usage. But like we have in the automotive field, as you can see, all the renowned names you will be able to see, starting from Ferrari, Volvo, BMW, Daimler. All of them are our customers. With that, thanks a lot for your time. And if you have any question, feel free to send it through the chat message. We will be answering towards the end. Thank you.
Okay, thank you, Papa. Now I'd like to invite Bud from Ansys, and then he's going to talk about the software development and safety analysis of automotive applications. In this presentation, Bud will introduce the two very powerful system simulation tool called Ansys Skate and Ansys Medini Analyze to help you in for the safety analysis across the life cycle to ensure the risk of automotive of autonomous automotive engineering. Okay, so but I can see your screen now.
Okay, thank you. Thanks, Marie, for the introduction. I hope you're able to hear me loud and clear.
Yes. Yes.
Okay, thanks for the confirmation. Good afternoon, everyone. So in this part of the discussion, I would quickly like to talk to you about a basic introduction to functional safety and the typical challenges that we have in the safety domain. We will look into the both parts of the story, from the hardware as well as from the software perspective. How do we achieve ISO 26262 compliance, and then just a quick summary of our discussion. Now, today, if you look at automotive, it is full of software and electronics. Today, if you are talking about innovation, this innovation was primarily driven through the electronics and the software. If you look at the structural parts of the vehicle, of course, there are significant improvements coming on that side, but predominantly the structural components of a vehicle are pretty much the same as they have been for decades. However, most of the new features and the functionalities that we talk about today are being driven from the software and electronics, and which is quite an interesting point. Now, with that, what's also interesting is to notice the way how things fail. Now, with a lot of these functionalities, features being enabled by electronics and software, there is also something that comes along with it, uninvited, and this is about the malfunctions. Those high-end features and the functionalities that we have implemented in our vehicles, they are likely to fail from time to time. And this is because all of these systems are designed, even though with best of our intention, best of our care, there is no possibility for us to ensure that 100% something cannot fail. This is just impossible. And so we regularly keep seeing these kind of information presented to us in the news that something has failed in some vehicle. So this is not about to talk any particular OEM or any particular tier supplier or as such, because this is common across the industry. It could be about anti-lock braking system, it could be about airbags, or it could be about traction control, it could be about unintended acceleration, you know it all. And the challenge here is most of these functionalities, especially the safety and mission critical functionalities in these vehicles, are driven through the combination of electronics and software. And our intention is to be able to make a systematic analysis about all of these functionalities and to ensure and to identify what could go wrong here and how could we prevent such things from going wrong by implementing the robust designs and implementing whatever is needed in our design, either to reduce the risk or to completely eliminate the risk as appropriate to the system we are working on. Now, with that, we have ISO 26262 standard that's been deployed in, that's been currently quite well established in automotive industry, and almost all OEMs and tier suppliers are following this particular standard to help them implement this robust best practices in their designs of high-end features. Now, for all those systems that are built with electronics and software, we have extensive guidelines provided in the ISO 26262 in different parts. So starting all the way from part 3, where we start off with the item definition, which primarily is defining the functionality, so the feature that is going into a vehicle, which could be, let's say, anti-lock braking system, or it could be a dynamic stability control, or it could be electronic steering lock, or it could be electric power assisted steering, you name it. So whatever is the functionality. Now, these functionalities are the traditional functionalities that we see today, but today we actually are talking about some things that are beyond the traditional functionality, which is moving into the ADAS and autonomous driving functionalities. It could be something simpler functionality such as lane keep assist functionality, lane keep warning functionality, automated emergency braking functionality. And these functionalities are going forward that take step-by-step incremental capabilities where we are going to achieve more or less automated functionalities in the coming years of time. So all of these functionalities are once again are driven through the electronics and software, because even for functionality, something like lane keep assist, you know that you need camera to monitor the road, and this information has to be processed through image processing, and your system should be able to understand where the road is, where is the lane marking, and then this information should be detected and processed by the system to understand whether the car is really running in the same lane, or is there any possibility that the vehicle is drifting away from the adjacent lane, and so on, and then bring up any kind of warnings, be audio warning or audio visual warnings. So these functionality, as you can imagine, is completely implemented with the help of electronics and software, and that once again is highlighting the growth of electronics and software in all these modern vehicles. Now, with the ISO 26262 providing us detailed guidelines about how to increase or how to reduce the risk associated with these functionality, it goes step by step in multiple parts. So part 3 defines a top level functionality, and it rather gives us the guidelines about how should we perform the safety analysis. So what we have to step by step perform the identification of the malfunctions, and then we have to identify what kind of hazards could possibly occur if so and so malfunction should occur in the design that I have put together in the context of the usage of the vehicle. And then we have to look into the details at the product development. We have to split this into two different concerns. One goes into the software side of the story, and the other goes into the hardware side of the story. And then there are a couple of metrics that we need to look into, and so on. So basically, ISO 26262 provides an elaborative guideline to the automotive community to reduce the risk associated with all these modern features that are going into our vehicles. Now, talking about the various activities that are part of this ISO 26262, at the very beginning, we start with the definition of the item. So item is at the very top level is a feature or a function that's going to be implemented in a vehicle. Now, this could be something as simple like electric power assisted steering system or electronic steering lock or anything else. Now, what are the functionalities of this particular item that I am bringing into the vehicle? So if it happens to be a power assisted steering, my objective is that whenever I try to rotate the steering, the system will apply additional torque through electronic motors, and then it will make it easier for me to drive the vehicle, like in the previous case where I don't really need to put in a lot of effort to maneuver the vehicle. Now, given that these functionalities are enabled with the combination of electronics and software, we understand that there are possible failures that might occur. The first thing is to understand what are the malfunctions that could occur in the system that I'm putting together. So this electric power assisted steering might fail to provide the required torque at a time when I'm thinking that the vehicle is easy to control. Maybe I'm driving in a straight highway and I have to negotiate a curve, but right at this point in time, my EPAS system fails and the necessary torque is not applied to the steering wheel, which means turning the car is going to be harder than normal. And that could probably is going to create a kind of panic in me that I'm not used to the level of torque that is required from the driver to control this vehicle in the absence of EPAS system. So which might result in some kind of hazard. So this is something that we have to analyze under different operating conditions of the vehicle, and then try and understand how could we mitigate this particular risk. And in case if we are not in a position to completely mitigate the risk, at least how could we reduce the risk to a level that is acceptable to majority of the people? So this is what's going to be our effort in terms of our systematic analysis. Now, with this thinking, we are going to go ahead to perform what's called as hazards and risk assessment, where we are trying to understand various usage situations of the vehicle. For example, the vehicle may be driven in the city, vehicle may be driven on a highway, it may be negotiating a curve, or it may be negotiating a hill or different terrains, or maybe vehicle is being reversed. What happens if the electric power assisted steering fails to perform its function under various operating conditions of the vehicle? So we will try and systematically analyze these situations and see what is the severity, what is the risk level, controllability, and what is the exposure. So these are the terms that are pretty well defined in the standard. Based on the values that are provided, we would arrive at what's called as ASIL rating for a particular combination. So the ASIL rating, as you might know, it starts at the QM, which basically to say that you don't specifically have to do anything other than the regular quality control measures you already have in the development process. And then it goes to level A, whereas certain additional requirements are imposed by ISO 26262, which incrementally goes up to level B, C, and finally up to D, which happens to be for the most safety critical functionalities of the vehicle. Now, at each incremental level, the amount of activities that we need to perform is going to increase. And at the same time, the metrics that are associated are also going to become more and more stringent, and all the way up to SLD, which happens to be at the highest level of our safety ASIL rating. Now, in addition to doing these kind of analysis, we also will have to look at the functionality or the architecture of the function that we are putting together and try and understand what could be improved in this architecture so that the risk associated with functionality will come down. And that is, we will have to do this analysis at the architecture level of the system. And then we move on to perform failure modes and effects analysis, failure modes, effects, and diagnostics analysis, then single point faults analysis, latent faults analysis, and a complementary approach from the fault tree analysis, then dependent failure analysis. Well, so the list of activities that we need to perform are quite significant. And all of these activities are going to take extensive amount of time for us to perform this. And so a solution like Ansys Medini would be the right thing for us to get started off with. Now, as we discussed before, there are two parts. One part is going to look into the development aspects of the software, and there is another part that deals with the hardware side. So let's get started with the software side. Let's quickly look into the software architecture that we could put together with Ansys capabilities. So here is just an example of a battery management system, a quick architectural representation of a battery management system that typically goes into electric vehicle. So I have my microcontroller, I have my control software, I have my battery connection, disconnection arrangement, I have safety mechanisms. All of those are implemented here in my architecture. And I will be able to explain what are the information I'm going to receive from the environment, which could be like whether the battery is connected to the load or the battery is connected to the charging circuitry, what is the current that is being drained from the battery, what is the temperature of the battery pack, and so on. So there are many other parameters that I need to receive here to specifically understand how should I control the battery in the electric vehicle. So this architectural representation gives us a high level visualization, and it helps me understand what are the possible issues from the safety perspective here so that I can improve upon those. So I could probably start building a fault tree analysis at this moment, or I could probably start doing a FMEA analysis on a complementary side as well, depending on what you prefer, and then understand which are the areas where I need to improve the safety of the system so that I can bring in the additional components, or probably I can increase the robustness of the software, I can increase the fault tolerance of the software. So well, of course, there are many other ways in which you could do this. So, but system architecture happens to be the first place where you would look at improving the overall robustness of your application. And once we have the architecture defined, the next thing that we move on to is to the actual software design, development, and implementation part. Now here we propose model-based approach for the software design and development, because model-based approach happens to be at a higher level of abstraction than the traditional hand coding. So most of the automotive customers, they probably are familiar with the model-based approach for the software development. However, something that's very important and different over here with Ansys is that we comply with ISO 26262 guidelines when we do the code generation. So we have this modeling solution which can help you graphically put together the algorithms that go into the control functions of your vehicle, which you will be able to simulate graphically on your desktop and see what's going on and how the algorithm is actually functioning. And then you will be able to automatically generate the code corresponding to the algorithm, which can straight away be downloaded or put into your target application, and then you will be able to execute those control functionality. Now, some of the very interesting points here is that when we move up to SLD kind of requirement, not necessarily SLD, it could be SLC or it could even be SLB. So improving the software deterministic behavior is one of the important ways in which you can increase the overall safety of the vehicle. And here, particular solution that is Ansys Gate software helps you in generating the application that complies with the requirement of ISO 26262 and gives you the deterministic code generation that will increase the overall confidence that you have in the vehicle, and at the same time it will help you achieving the compliance with the ISO 26262 standard. So the application is not only about creating the architecture, design, development, and code generation, but it also takes us into the testing phase where we could write the test cases with regards to the top level requirements we have, and then check whether the application completely meets those requirements or not. And the tool will automatically be able to execute those test cases on your model, come up with the results saying that, yes, these are the test cases that where the expected result is matching with the actual result. And then probably if there are deviation, it can show you those things. And then it can also help you provide additional information such as model coverage information. So which piece of the model has been tested so far, where you have the weakness in your overall coverage, which portion has not been covered so far. So you will be able to look at all of this information so that you can enhance your overall coverage of the model so that you have the compliance that is necessary from ISO 26262. So I talked to you about code generation just before. So we have a tool called KCG that stands for Qualified Code Generation, code generator. And this particular solution is certified to ISO 26262 standard to be used all the way up to ASLD application. So which means the code that is generated through our code generator can assure you the compliance to the standard. And then we have plenty of documentation that can help you in making sure that your overall development is in compliance with ISO 26262 requirement. However, as I talk about ISO 26262, we are not only limited to ISO 26262, but we also have support for DO178C, which is primarily used in aerospace and defense, and EN 5128, which is primarily used in railways, and 6158 for industries and nuclear applications and so on. So this is basically the same code generator that we use across the different domains, which means this has been proven in the industry for a very, very long period of time, which once again should give you enough confidence to deploy this application development in the automotive systems as well. Now, I would like to move over to the integrated safety analysis from the hardware perspective included. Now, as we discussed before, so we start with the item definition, and then we move on to the malfunction derivation. Then we perform HARA analysis, and we will have the requirements for our application. So these requirements are probably stored in some external tool like JAMA, DOS, DOS-NG, and so on. Or maybe if you are not using any of those requirements tool, there is a possibility where you could straight away start creating those requirements within Medini Analyze tool itself. So with that, you will be able to set up the traceability of requirements into the architecture and rest of the downstream work products so that you have your requirements tracing down to the actual component where this functionality is being implemented. And then moving forward, we have various capabilities of your safety analysis or safety analysis techniques as such being implemented in the same tool. So when it comes to the architecture again, you can do it with SCADE Architect is the one that I just talked to you about, SCADE Suite and testing that I talked about just before, or you could do it with other tools such as maybe from IBM Rhapsody or maybe Enterprise Architect or maybe MATLAB Simulink. Now, of course, there is no dependency on any external tool. If you want to do it in Medini Analyze, we provide you a SysML editor within this tool itself so that you could create your vehicle architecture right over here. And then to support the complete safety analysis, we support FMEA analysis here, then FMEDA analysis here. We support both qualitative, quantitative, fault tree analysis, safety plan, and then checklist and so on. So there are a bunch of features that are supported in Medini Analyze to help you develop these kind of analysis on the system that you're working on. And something that's also equally important is about the reliability prediction of electronic components. So for each of the electronic components, we know that they suffer from random failures. Now, there is a particular failure rate that we can predict or estimate given a component, the quality of the component, and the usage environment of the component, maybe the stress levels and so on as applied. So there are multiple failure rate catalogs, or the handbooks as they are called, that are built into this particular solution, using which you will be able to estimate or predict the failure rate of individual components. It could be resistor, capacitor, integrated circuits, or many other components from the electronics domain. And then finally, we will be able to add up all of these failure rate together at the module level. You can understand what is the failure rate of your overall application or overall hardware. And then we can perform your diagnostic metrics, diagnostic coverage analysis, where you can understand whether a particular failure really contributes to the violation of your safety goal. And if it does, then do you have any mechanisms to detect such failures? Or do you have any mechanisms to prevent such failures? And what confidence do you have in the mechanism you have put together? And finally, what is the residual failure? So this approach can be used both for single point faults as well as the latent fault metrics. And finally, tool will be able to give you a consolidated set of metrics, including the overall failure rate, single point fault metrics, latent fault metrics, and then PMHF metrics as well. So which means in one single solution, you will be able to address various requirements of ISO 26262 from the automotive domain perspective. Not only that, we provide integration with multiple third-party tools. So to bring in the requirements, to import the architecture, and to generate the reports, for example. So you could generate PDF reports or Microsoft Word documentation, or maybe you can export these documents into Excel and share it with the other clients, or maybe your stakeholders and so on. So these are some of the interesting capabilities that are combined into the Ansys solutions. So that's pretty much what I wanted to talk to you about today. Thank you very much for your attention.
Okay, thank you, Bart. So next we're moving to our last session for today's webinar. And then I'd like to invite Avanesh from Ansys to talk about the solutions for automotive lighting and VR. And Avanesh is the lead technology specialist in Ansys. Okay, and in this presentation, he's going to talk about our new distributed Ansys optics solutions. Okay, and also the VR solutions. So, Avanesh, you can move on to your presentation now. Thank you. I think you're muted now. Hello.
Avinash, you're muted.
He's unmuted now, but
Still not so.
we still cannot hear you.
We don't hear you, Avinash. Maybe you can drop the headset and.
Cannot now. Cannot.
You hear me now?
Yes.
Okay, thank you.
Okay.
So I'll share back my screen. Okay.
Okay.
Thank you, Mary, for the introduction. And hello all. Myself, Avinash Padmapa. So today I present on the automotive lighting and the VR applications. So this is the index. We'll walk through that, and basically to give a quick introduction about the product I'm focusing. Ansys has various physics in offerings, and the light simulation is one of the physics where we can simulate within visible light range, infrared, ultraviolet, the wide spectrum of the light simulation. So starting from design, optics, doing a photometry, pursuit quality, and doing the sensor simulation is all covered under this physics. So let's see how do we manage, what kind of solution you can look at in Ansys portfolio. So before I go ahead, just to give a quick overview of the products I'm focusing today. So there are two products, this POS and the AV Accelerate sensor simulation. So, so both of them are meant for the design and for the validation, which I'll be working through in the coming slide. And this software has been certified for by CAE certification for the accuracy for the theoretical and for the validation for the benchmark products. And we can also work on day and night for different lighting condition. So it's not only the light emitted by the various product, but we can also test it for the ambient lighting definitions. So the main aspect in this product or the application is the visual ergonomy. So this is basically to see how the product will be perceived by the human eye. So there is a lot of difference between the photo taken of a product or of an environment or of the surrounding and the way human eye perceives. So human eye is very complex sensor mechanism. which works differently for a lighting conditions and the amount of time we expose, and and also the age factor and few difficulties with the vision, with the color blindness, or with various aspects of that. So to understand this on our product, so if I'm working on a display, if I'm working on a mood lighting or a functional lighting, and if I want to achieve a certain level of the brightness, the vision in different day conditions or the night conditions, and uh, I want to look at the ergonomic point of view, how it is going to create a fatigue on the user. So we can do all these kind of studies here. So it's not only a photo we are looking at, but we are also doing a simulation virtually to see how the light distribution is happening. Where are my hot spots where light is more accumulated, or where are the dark spots where we have a less light? So we can see in a different color plots, and then also steady if it is going to create a washout or a reflection or a glare. So we can study those kind of things. So this is completely achieved if you have a very good input, and if the solver is accurate to solve all the equations related to the reflection, diffusion, refraction topics. And finally, we are seeing the results in our display like a monitor or a TV. So the recreation should be very accurate so that when we see the real product or when you see the simulation result, it should be comparable. So that makes it more accurate. So where we have very strong uh, the product positioning in this area. So this makes it's not only a stunning result, but it's very accurate result as well. So let's see the results for different application. So I'll start with exterior lighting, and we have seen different lamps in the current model. So it's no more a low beam, high beam, or a turn indicator alone, but we have so many new functionalities coming into the lamps. So how can I make sure the these lamps are gonna work effectively for the new car line we are developing? And can I do a test drive? Can I check my software or the control logic which supposed to make some changes based on the vehicle detection or the pedestrians? So all these kind of testing, how can I do it virtually? So that's something we can achieve it with the product. So very first step is to get an experience of the product, to see the product visualization, um, visualize from different angles, check for the same lamp. Can I try with the different ideas, which looks good? And how can I convince my management to go ahead with this kind of lamp design? So that's something we can do it very effectively, very easily. And then we can also try with different ideas and check how much it is going to illuminate in the street. So we can have a virtual sensors or the measurement area to see the light distribution over a distance of 100 or 150 meters. Check for the regulations for different countries, whether it's meet the regulation or not, and also create a virtual scene to get an idea how much it is illuminating. So the step next to that is on the validation, where we want to drive through a scenario. So the scenario could be my test track available in the company, or it could be a dedicated test track available from various institutions or from the government agencies. So before I go and set up my complete vehicle for a new lab and do the testing, can I do a test in my desk? So that's something which we can support you as well. So there are tools for us to support creating a scenarios or creating a complete test track, and are available to create a control law, and basically uh, to to recognize the vehicle in the surrounding like a traffic, So I could be following a vehicle, or there could be a vehicle coming in front of me. So I should detect that and switch off the LEDs, which are basically illuminating in those direction as a I-beam, so that I don't put a glare on the oncoming vehicle driver's eye. So that's something the camera should recognize, make a decision, put it back to the LEDs or the headlamp, and then experience whether it could able to make a detection quickly, and it could switch on or switch off, and we could experience that. So as we can see here, so we have the control logics built, and we have different configurations of lamps to get an experience. So I could have a design A, design B, design C, or the matrix beam, pixel beam, different kind of lamps, and then illuminate those, see in a virtual track how effectively this is working. Is there any lag, delay, whether the camera is not enough, not able to detect the objects, or it's taking some time. So we can experience all these. So this is on the exterior lighting, and let's take a look on the interior lighting as well. So with the current industry evolution, there are a lot of enhancements happening on the interior lighting, and we could see a large displays or the touch screens inside the vehicle, and a lot of mood lighting or the connected lighting, which is basically also an human machine interface for the ADAS. So if I'm in autonomous vehicle, and if I have to keep informing the people inside the vehicle that the system is in healthy condition, it is taking care of everything. So how can I make this communication? So that's also more important as a connected lighting. And there are different roof lamp designs, star roofs, and other more lighting conditions. So the challenge is to get the different suppliers well connected, and they produce a similar lighting experience, irrespective of whether the lighting is in the door or in the instrument panel or in the seat or in the roof. So each supplier should speak the same language and make a similar design. So that's something where we can work out. So let's take a look at a few examples. So here we are looking at the visualization on the large on a display or a touch screen, and see how much of glare is there from a different visualization point. Even though interest is on the driver vision, but we can create a different vision points. So that's not the limitation. And we can also create different themes of different interior plastics, fabric, and the lighting condition, and see which looks better, how the light color and the material are interacting, and how good is my the complete interior. So that's something we can experience. So now we talked about the interior and the exterior lighting, and let's take a look at the sensor simulations. And so we are working mostly in visible light range when I'm in exterior or interior lighting. But when you're coming to the sensors, so depending upon the sensor, whether it's a camera, lidar, radar, so the frequency range is different, and each sensor has certain advantage over the different lighting conditions and the weather conditions. So we have to make sure that the sensors we are selecting is suitable for all type of use cases or the edge cases we are working on. So building a confidence on the sensor we are using is quite important, which we can test it and validate using the products from Ansys. So there are different products considered here. So in this case, I'll give an introduction for camera, but we can also talk about radar, lidar, or the thermal imaging, or the thermal cameras. So the when we looked at the sensors, we can work on the component development. So the optic creation itself, and see what kind of field of view it could have, what kind of noises it create, or what would be the distortion, vignetting. So the different challenges with the camera. The same way with the radar or lidar, with cross communication, with the energy loss. So we can look at different challenges altogether, and then work on the vehicle integration, bringing these sensors, mounting on a vehicle, create a different the visualization. So how can I find the optimum location, considering the structural CFD or the styling team inputs, and still achieve the desired the ADAS output required. And then finally test it for ADAS or autonomous vehicle development and the validation. So whether it could be software in loop, or it could be hardware in loop, or vehicle in loop. So we can do the validation on the right side of the vehicle. So to understand more on the camera, so we have tools to or the methodology to design the camera. It could be starting from Zemax and importing these informations into the software, where we can do optical simulations along with the rest of the vehicle, rest of the scenario, and see what kind of vision we are getting. And also we can do a multi-physics simulation to see how the packaging will affect to the performance of the camera, the ambient or the sun loading onto these optics, or there could be a other LED in the near area which could be creating a flash on the camera. So we can study different aspects, and then also see what kind of vision the camera will get, whether it's a clear sky or it's a foggy conditions, and then run a co-simulation, see how effectively my perception algorithm is working, and what is the confidence level on the system. So these are the things which we can check. So to give some more idea how we can run these simulations again on the day, on the fog and the night condition. So this is a simulation output where we can position the vehicle or the traffic at different locations, or get different signboards, traffic poles, or a pedestrian, and see what kind of vision is going to get. So it's not only a clear sky or a fog condition, but we can also model the rain simulation. So it could be as accurate as a light rain, moderate, or a heavy rain modeling, or a splash from the vehicles surrounding, or a droplets kicked off from the other vehicle. So we can create different scenarios, or get the information from CFD and use it here for the modeling of these droplets, and then do the simulation as well. So that's completely possible. So then at the end, we can see how parameters of the camera provided by your supplier, whether it could be just a data sheet or a distortion curve or a complete information. So we can, based on the information available, we can do this camera modeling and run through this scenario, get a set of images or a video to flash it onto your perception algorithm. I can see the resolution I'm using for a camera. Is it good enough to detect a person? Can it identify the people with a different forms, different clothes he is wearing, with a backpack, with an attachment, carrying some luggage? How the perception algorithm will detect? So those are the things which we can check here. So with this, I mean, the summary is basically to see how we can use these simulation tools for lighting and for the sensor simulation. And here we are considering all the physics property of a material. So we have a methodology to capture the reflection property of a material or the transmission properties. And also we have a huge library which can be applied onto a different objects. and then solve all the equation to see finally how much light coming back to the human eye or as a sensor, and we can easily identify whether it's going to create an issue to the camera. Do I need to have a different type of camera or even for the human eye? So we can check those kind of things. And we can also work on multi-physics simulation to predict the life of the product or improve the performance of the product. So we can work with mechanical, thermal, CFD simulations. So thank you very much for this opportunity. Thank you all.